We're going to try this solder tutorial. This camera mounted on my head. It's not the most ideal situation, but I tried one with a mounted camera. Couldn't see the details and the camera just wasn't close enough, so this is a soldering tutorial. So you got this nice audio cable that's hooked up to your audio equipment. And then your friend George comes in, walks over and goes, snip. Oh God, I don't know why I was doing that. I was just spacing, bud. I'm really sorry. So what are you going to do? You're going to fix it. How are you going to do that? Well, I'm going to start by stripping the cable. So you take your little wire stripper, and this is just a cheap little wire stripper. And on the bottom of it here, or on the side of it, we have this number goodie set for the gauges of the wire. I don't know if you can see the numbers on that. Really can't check the camera from where I'm at, so we'll hope this works out. So outer part, strip off, and you're going to strip it back a little ways. Your wire strippers, or however you do it. If you don't have any wire strippers, you can use a pocket knife. Once you got it that way, you can separate out the braid. This is a shielded wire, the outer conductor braid. Braid keeps RF interference from getting in or out of the wire. Very important. Now come on, separate it. Twist the braid up. Make it a single conductor. Make sure all of the wires are twisted properly. For a particular reason, we're going to take a little snip off the we're going to put this at about 22 gauge, I think. 24, most 22 works. Pretty thin wire. And strip a little bit off. So 22 gauge. See what we've got. Now we're going to do exactly the same thing on the other wire. So about soldering. Mess around here. I'll get the video out as soon as I could. So your wire needs to be perfect, shiny, and oxidation. Any oxidation on the wire will cause the soldering not to work. Wire needs. Now, you have oxidation on the wire. Cut it off as much as you can, depending on your size of wire. Normally, if you do something like this, you'll have oxidation because the wire has been until it was snipped. So you don't need to worry about it. Wire's oxidized, got issues. There's two things. Number one, when you buy your solder, make sure you have solder that is, hopefully you can see this, solder that has built-in flux in it. And the flux is what helps solder flow and clean the oxidation off the wires. Now this is for electronic solder, and this is pretty standard. It's a 60-40 mixture of tin and lead. There are some solders that do not use lead, and then there's silver solder, which is another thing, but this is pretty much the standard, and they've got a replacement solder that's pretty much the standard for not using. So you want your solder to have flux. If you have something that's badly oxidized and you're not sure if it's going to solder, because if it's badly oxidized enough it won't. You've got this lead-free tinning flux. It says for use with any lead-free solder, but it seems to work just fine with regular solder. And you can dip your iron in this, or you can dip the wires in this, and then when you heat it with the iron, the flux will burn off as a smoke and will clean your stuff up. So we want to talk about soldering tools first. Before we solder these, we're going to talk about some tools. Sorry about the noise, this plastic thing. So this is a nice Weller soldering gun. So, you don't want to use these for your basic soldering. It's much too powerful. This one is a 260 watt and a 200 watt. That means it's got two power settings. It's a nice Weller. Okay, so it does not heat up until you push the button. Well, there's the first setting, low setting, and then the trigger will push in farther. Give another click, and then you're on high setting. 200 or 260 watts. Now this is good. If you're using this indoors, you have to watch about melting insulation on your wires. You never use something like this on a... It's melting the solder already, so it's already hot. So that's all the time it takes to heat up. You use this on a circuit board with traces. You'll burn the circuit board, you'll burn the circuit board traces, and they will lift up off the board and detach. And not only that, you'll undoubtedly burn up insulation stuff. If you were to try to solder any wires this small with this type of thing, you burn up the insulation and melt them. So this is for heavy duty jobs, or in some instances, I recently used this to repair an automobile that needed solder work outside. The wires were fairly decently sized, but they weren't particularly heavy. But if you've ever tried to use a regular soldering iron outdoors, you'll find it just doesn't work. Any slight breeze will take the heat right away from it. Breeze and wind. So it'll suck them dry and they'll act like they're not even hot. You won't even get your solder to melt. So that's why you need something like this. I was doing it out. I live on the coast, and so it was windy out. But it did just a fine soldering job. So if you need to do soldering under severe conditions or something, this Weller is a nice one. If you're going to buy a soldering gun and you want to use it for something like that, go at least something this size, 250, 260 watts on high. And that'll make you a good soldering iron gun. You just can't use it on something you shouldn't. And by the way, we're going to talk about tips too. The tip has to be clean, and it has to be what's called tinned. So if the tip of your iron gets oxidized, now this is just a standard standalone iron, and it looks like the cord got burned there. This is a standalone iron, and they're usually not this big. This is only a 40 watt iron, but usually a 40 watt iron is smaller. Not this physically big on the end and this big tip on it. So even though the wattage is okay for soldering iron circuit board, this tip is just a bit too big and doesn't work so well for that purpose. I should replace it. The tips just come off, and you can replace them, and they should be kept snug or they won't conduct heat. So this one should be tightened up just a little bit with a pair of pliers. Quick. But I seldom use this iron because the one I prefer to use is this Weller soldering station here. Now this is a temperature controlled soldering station. The previous iron that I showed you, this one that just plugs in, has no switch or anything on it. If you leave that turned on, they'll usually burn out. Don't leave it on overnight. A lot of times they'll just burn out. They don't work well with it. This particular one, this one here, this Weller, this is a temperature controlled soldering station. And we're going to look at the tip here. This tip is in pretty good shape. If they're bad, or they got corrosion on them or something, you need to clean it off, scrape it off, scrubby like I'm doing right here on the bottom end of the sponge. Sponge needs to be wet with a little bit of water. Make sure it's damp in there. That's enough. Anyway, we'll put this there. It heats up pretty fast, but it takes a little bit slower. But it is temperature controlled and such. So, get your tip all nice and shiny, and it needs to be tinned, which means rather than being oxidized, good to melt a little solder onto it like that. Just make sure it should be shiny and not dull. If it's got dull oxidation on there, you want to get it off. So your iron should be good and tinned. That way usually works pretty well. Ideal if you have a solder pot, you melt the solder and you dip the tip of the iron in it, but that's not very helpful for people who don't have a whole bunch of money to invest. So this little tool, I think this thing is just called a helping hands. This is an old one. I've got a fancier one, but it's temporarily in abeyance for location. And that's what we're going to clamp our wires in. But we're not going to do that yet because we're going to use some of this. So this is how we're going to solve our insulation problem. We're not going to put black tape on it if we can avoid it, because black tape has a tendency to come off. And has some issues in general. Yeah, this should work. So we got a piece of this heat shrink tubing. Now what this does is when you apply heat to it, it shrinks up around it and forms a solid sealed insulator around the wire. So we're going to put a piece of this on there to start with. Sorry, I'm holding it up as if I tried making this video yesterday without a head-mounted camera. It came out really bad. Couldn't see anything. Couldn't get close up enough, and everything was blurry. So I'm hoping this will do the trick. So you need a long piece, and that piece is going to cover the whole outer part of the cable. So now we need some for the inner conductor. So I'm going to need it about that long. So it would be good if we cut this down just right. Snip. Out here. Cut that thing sharp enough to snip. just a little more. So what we're doing here, this piece has to be clear of the wire when we solder. If it's too close, the heat of soldering will just melt the wire. So we're going to take, now that we've got that on there, we're going to take, just twist our two center wires together. We're going to twist them this way, make them nice and flat and smooth. And what that means is our heat shrink is going to shrink around there and make it nice and so. Got that. Put it in our little tool for soldering it. Now, when you apply the solder, so hopefully this is good enough that you can see our wire there. Shiny. Nicely twisted, hopefully. We'll see if this works in post-production. Okay, so we're going to take our solder. Now, our iron is good to go. I usually put a little blob of solder on there and just find it just works better and touch that little blob of solder you just applied to the underside of the joint because heat rises, okay? Because you're not trying to melt the solder onto the joint. You want to apply the solder to the wire and let the wire melt it. Do that. Notice how it's, now you see that? How it's nice and silvery now? That's just exactly what we want. Now, when the solder's on there, you need to let it dry. Give it a moment. Even though it's metal, it still takes a moment to harden. Give it a moment, and if you move it or bump it while it's drying, it'll often cause what's called a cold connection. Now, I'm not sure how clearly you can see that right now, but it's very nice and shiny, which is just what you want. It's small, and we haven't burned our insulation much. We're good. So we'll slide the heat shrink over that centerpiece there. Right over it. Now, I've apparently forgot my heat source, so I will be right back. Okay, here we are again. I hope you all can see this, or I'll be trying to shoot this video yet again. All right. The problem is the computer isn't in a place where I can watch the screen when I do this. Okay, so we've just shrunk our heat shrink. Now, there are different tools you can use for this. They've got hot air blowers and things and this and that, yada, yada, yada. But a lighter works fine, really. As long as you're doing something like this and you're not trying to inside a piece of equipment or something. Obviously, you always have to be careful with the lighter if you're using it. So we're going to do the same to the outer conductor here. Twist it together. And we're going to get this. Try and get this relatively tight here. Got a smidgen off there too. They just seem to have a little bit too much wire on there. You want everything to lay flat so you don't have a problem after you're soldering it of putting the heat shrink back over it, because if you do a blobby solder connection or get lots of extra solder on the wire or anything like that, and it just makes the heat shrink hard to apply and it doesn't make a smooth, nice connection. It's a blobby thing and you don't want that. So We'll twist it together just a little bit here. We'll pull this as straight as we can here. Did I cut off too much? Almost. Twisting that the wrong direction again. All right. I usually don't have trouble with things like this because I do them without thinking. Now that I'm doing it for a video, I'm thinking about it. If you know how to do something, you've done it a lot, then thinking about it throws you off. Of course, if you don't think about it, then you forget to explain a lot of things to people. Okay, so they're saying that looks pretty good. A little bit of solder, apply the heat. This iron, you have to check every now and then. Since it's temperature controlled and you have it in this thing, and it'll heat up and then it'll, oh, I turned it off. Wow. I don't remember doing that. Well, that would be why the solder isn't melted at the moment then. Silly boy. Give it a second to heat up here again. Come on. Of course, don't forget the water on your sponge. You might find you have a smoky sponge. All right. I think that should be good enough. Now we're going to apply just a little bit. And it should run along the wires and seep right in. It shouldn't be blobby. That's what you want, a nice, good connection like that. Okay. And then you move the heat shrink back up over it. And we kind of used too big of a piece, but that's okay. We'll just shrink you up a little bit. See how nicely that shrinks up and conforms perfectly to the wire. So there you go. Now you have a perfectly repaired 100% connection. And that is a solid insulator. It'll stay in place. It won't cause you any problems. The glue won't come off like black tape will do. That's pretty much a permanent fix. So there you go. That's how to use solder to permanently fix a connector. Now, if you have any other questions, please let me know. Any other things we need to do solder wise, any other things of that nature. I can't think of too much else. Soldering on circuit boards we could do if that's a thing that people are interested in, like how to remove components or solder a component in or work on a circuit board using a small iron. Like I say, a 40 to this is a 60 watt, I believe, but since it's temperature controlled, you don't have to worry about it. It's also grounded, I believe, so you won't end up with any static electricity from your soldering iron, which can cause problems with circuits. So there you go. Hope y'all enjoy it. If you do, please subscribe and like, and I hope to have a bunch more videos coming soon.